with the help of a chemical equation, we can find out how many grams of each of the reactant takes part in the chemical reaction, and after the chemical reaction how many grams of the product forms. This is very important information which can be obtained from chemical equation. But to find out this, how many grams of reactant takes part and how many grams of product forms, to find out this we have to know first atomic weight or atomic mass of different element. So I want to present here 20 elements in the increasing order of their atomic number, and I want to give you their atomic mass. How to remember very easily their atomic mass? Look at this. The element: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. The atomic number of these elements is in increasing order 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the same way, atomic number from 11 to 20: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. And this is the number of proton, which is also atomic number. Atomic number is actually the number of proton. But if we remember number of neutron also, then number of proton plus number of neutron gives us atomic mass. And we must remember atomic mass to find out the weight of reactant which takes part in the chemical reaction, and with the help of this we'll find out the weight of the product also. So let's go through atomic mass first. Hydrogen is neutron, 0, it has no neutron. Helium, number of neutron is 2. But from lithium to lithium, beryllium, boron, how many protons are there? One more neutron is there, 4. Here beryllium, proton is 4, that's why here 5. Boron 5, that's why here 6. Hydrogen and helium is different. Lithium, beryllium, boron, 1 more than that of the proton. Number of neutron is 1 more. Now carbon, nitrogen and oxygen, remember these three also. The number of proton and neutron are equal here. And B1 oxygen from 9 to 20. There is only one exception. In case of argon there are 22 neutrons, but if atomic number is odd, then number of neutron is 1 more. For example, here atomic number is 9 or number of proton is 9, so it has 10 neutron. 11, that's why 12. Here atomic number is 13, that's why 14, and 15, that's why 16, 17, that's why 18, and 19, that's why 20. Now if their atomic number is even number, number of proton is even number, then number of neutron is also the same. 12, 12, 14, 14, 16, 16, now 20, 20. Now with the help of this table, if you keep this table in your memory, we know the atomic number, there is no problem to remember this atomic number. But if you take this number in your memory, then you'll be able to find out atomic mass easily. Just for example, fluorine atomic mass is number of proton plus number of neutron, 9 plus 10, 19. And neon, 10 plus 10, 20. And aluminium, 13 plus 14, this is 27. This way, if we have this in memory, atomic mass, then we'll be able to find out how many grams of reactants takes part in the chemical reaction and how many grams of product forms. But the major point is these elements should be involved in that chemical equation. Okay, let's take one example. When potassium chlorate KClO3 is heated, then we know that it decomposes into potassium chloride and oxygen gas. Now I want to balance this equation. Oxygen 2, here it is 3. If we put here 2, 3 2s are 6 oxygen. Here 2, 3 2s are 6. Now let's talk about chlorine. Chlorine 1, chlorine here 2. That's why if I put here 2, chlorine balanced. Now potassium 2, potassium 2. This is balanced chemical equation. Now look at this, 2 is here, 2 molecules of potassium chloride, that's why I am writing 2. Now, potassium is atomic mass. look at this, 19 plus 20, 39. Plus chlorine, its atomic mass is 35. 17 plus 18, 35. Plus, now 3 atoms of oxygen. That's why 3 multiplied by oxygen. Look at this, 8 plus 8, 16. Now this 39 is atomic mass. This is atomic mass. This is also atomic mass. But when we multiply and add all this, then we'll get molecular weight of this potassium chlorate. Molecular weight of 2 molecules of potassium chlorate. That I am going to calculate. Now let's take this also. 2 potassium, I have written here 39, plus this chlorine 35. And here 3 molecules of oxygen, and each molecule contains 2 atoms of oxygen. Now if we calculate this, 39 plus 35 plus 48, and here it is 2 into 74. This is equal to 3 into 32. Now the final number is 244 if we multiply, and here it is 148, and here it is 96. Now we can conclude that 244 grams of potassium chlorate when decomposed, then 148 grams of potassium chloride forms along with 96 grams of oxygen. We can write this 244 grams of KClO3 decomposed to form 96 gram oxygen. If question says how many grams of oxygen gas produces when 15 gram of potassium chlorate is heated, then we can calculate easily. If 244 gram of potassium chlorate decomposes to form this much gram of oxygen, then 1 gram of potassium chlorate decomposes to form 96 divided by 244 gram of oxygen. And if the question asks you that how many grams of oxygen produces when 15 gram of potassium chlorate is taken in a hard glass test tube and decomposed by heating, then we can calculate by putting this number. 15 gram of potassium chlorate decomposes. When decomposes, then it forms 96 by 244 into 15 gram of oxygen. And if we multiply 96 by 15 and divide by 244, then we'll get 5.90 gram. This way, how many grams of reactant takes part in the chemical reaction and how many grams of each of the product produces can be easily calculated with the help of this table. So it's better to have this table and remember the atomic mass of 1 to 20 elements.